Thank you for the invitation. I am RIGOLOT from a research unit in Avignon, southeastern France, on the ecology of Mediterranean forests and studying the relationship between different forest risks, entomology, drought, and forest fire. I have a background on forest fire, and now I am more involved in the governance of research on risk and multi-risk. My presentation will be
une fois qu'on fait ça, normalement ça marche.
okay.
Ouais, faut juste faire une première fois.
So there is two parts in my presentation. The first part is about forest fires, to make the link with the field trip we had this morning. So the application of the IPCC framework on terminology on risks related to forest fires. And in a second part, I will come to the multi-risk aspect as a concept, but also applied on the forest ecosystems. So let's start with the risk component applied to the risk related to forest fires with the now well-known propeller of the IPCC. This is the version of the assessment report of 2014. At that time, we had only 3 blades on the propeller, the crossing hazard with the exposure of the stakes and the vulnerability of these stakes. And laterally, you have the pressures, climatic pressures and socioeconomic pressures in terms of processes that applies on the risk system. And it's important to note that at that time, the adaptation and mitigation actions, the solution were outside the system and already not included in the system and was part of the socioeconomic process with, of course, feedback effects on the climate processes. Let's apply this framework to the forest fire risk with, for the hazard, 2 components. First, we have the fire occurrence, which depend on meteorological parameters, of course, the vegetation sensitivity, flammability, and the human aspect, which is fire ignition. It was told this morning that 90% of the fire are due to human actions, and only 10 the natural ignitions by the strikes. So these parameters are changing on a daily basis. So it's a conjunctural component, which we call the fire danger. And then we have a more structural component linked to the biomass, which change very slowly during the year, and which make the fire intensity, and which make the fire harder to fight when it's ignited. So it's usually called the fire hazard. Then we have a lot of assets that are threatened by this hazard. Of course, the forest itself, the forest burns, so the forest is damaged. So it is the first to be taken into account with all the ecosystem services that the forest offers. But inside the forest, you might have several human infrastructures, including buildings that are threatened by the forest fires, and of course, human lives, people living in this context. So it's very important to define which are the assets threatened by the hazard to start an assessment of a risk analysis. And each of these assets have a specific vulnerability. The forest itself has a vulnerability which depends on its structure, its composition. The buildings inside the forest that are threatened by the fire the vulnerability depends on the construction methods, the materials. Here, a wing with the houses of the three little pigs. And of course, the human beings which live in the area. And again, the vulnerability parameters are the age, the welfare, the health. And this is something that has to be better studied. Now let's come to the fire management. Here again, a representation of the IPCC, quite interesting because it shows the solution, the area of the solution for resilient development, and it can be applied on each component. Each component, here the white arrow represents the reduction of the hazard, here of the exposure, here of the vulnerability, and the green area represents the global risk reduction that can be applied by the risk management. But this is limited by this gray line, which makes the frontier with the central part, which corresponds to the residual risk after adaptation. That means the observed impacts of the disturbance of the threat. Let's apply heat to the forest fire. The first action we can do to mitigate the forest fire and the hazard component is to reduce the ignitions with a proper public awareness and with some action to increase public culture on this kind of risk. And of course, the fuel management, which is fundamental in the mitigation of the hazard so as to reduce the fire intensity and to make the fire able to be fought by the firefighters. So fuel management, locally or globally, are a great option for hazard reduction. Of course, the limitation of the asset as threatened by the hazard is another way to reduce the risk. Here, we concentrate on the urbanization with the limitation of the authorization of building and also some recommendation on existing buildings to limit the exposure of the building to fire. And finally, several ways to reduce the vulnerability of the buildings, a specific asset to be protected, by applying the famous obligation légale de débroussaillement, the fuel treatment on a 50-meter radius around the houses, and also the access to these houses at a minimum of 3 meters on both sides of the road. So this is a good example of the way to mitigate the risk by limiting the vulnerability of the building. I would like now to present you some results from our research group and the projection, the modelization of the fire danger, and the projection of this prediction on the coming decades. So we have developed a probabilistic model called Firelihood, and here are some contextual elements. The context is that the climate change will induce meteorological changes that will induce a change in the fire regime. And the two main mechanisms are, first, the living plant will get drier and might even die when the meteorological drought is intense. And the second phenomenon is that the dead vegetation, for example, the litter, will get drier due to the deficit of water vapor in the air. So these two phenomena will concern all the compartments of the fuel, of the vegetation fuel. and will make the vegetation more flammable and more combustible, easier to ignite, but also more intense fire, and that will change what we call the fire activity. The fire activity, it's a synthetic indicator combining both the fire occurrence and the fire intensity. And the fire intensity here is looked through the size of the fire. So the probability that a given fire exceed a certain threshold in terms of dimension. And with this kind of model, there is a lot of scientific question on the magnitude of the effect of this change in fire dynamic, and also the timing of on the trajectory of the territories that will be impacted by climate change and the induced change in fire regimes. So the fire livelihood model has an input with what we call the Forest Weather Index. It's an international index mostly used combining meteorological parameters applied on the Safran grid, 8 kilometers, with some information about the quantity of fuel, the quantity of forest in each pixel. And the output of the model are first fire occurrence, that means fire exceeding 1 hectare. It's considered as a true ignition. And then the probability of one fire to exceed a given threshold, 10, 100, 1,000 hectares. And we can do several runs of the simulation and make a series of calculation of analysis to explore first the projection on a given area. Here it is southeastern France with the 15 departments of the Mediterranean region, but we have also applied it in the southwest and in other European regions. Calculate the future expansion of the fire risk, but also its intensification in the historical region like Mediterranean France, and the lengthening of the fire season from which is now July, August, but in the future it will be more June through September, and impacts on the ecosystem and impacts on the fire management and firefighting strategies. So the main result I will show you today is a simulation of fire occurrence exceeding 20 hectares. As we have seen this morning, it's quite rare, still rare in department as Isère, but it's very common in the Mediterranean part of France. So simulation on projected between 2000 and 2100 with the two IPCC scenarios. And here is the result for the current situation. We can distinguish three zones. We used to know the two main south zone with the Mediterranean region and the southwest, but there is also in France nowadays already a third zone, which is center-west, Région de la Loire, which is already impacted by fire. And the results of the fire livelihood simulation show a different time step that we will have an increase of the fire risk in terms here. The indicator is fire exceeding 20 hectares. By 2050, it will be a 60% increase, and by 2090, a 200% increase, with the three zones merging, converging, and covering almost 2/3 of France with the forest fire risk. So it's more visible if we look at the department aggregation. We can see that the hierarchy between departments is not pretty much changed during this evolution. The historical zone will remain the main risk of forest fire, but there is an extension around each of these zones with new departments appearing on the map, Ariège, Lozère, here, And even in the center, departments like Le Cher, like le 18, c'est... Ah, les cours de géographie. Personne ne sait répondre. Bon. Par contre, celle-ci, this one, it is for Isère. So Isère is nowadays a very department where there is not, there is some fires, but not so big. But in the future, whereas today it's one every 5 to 10 years, it will be by the end of the century, one every 2 years, which will need an adaptation of the system of prevention and fighting of the department. Let's skip now to the question of the multi-risk applied to forest, not only forest fires, but the other threats that you may know in the forest. Coming back to the same propeller, in the last report, the IPCC added a new blade corresponding to the responses. The solutions were integrated inside the risk system for the assessment, considering that for the climate, for adaptation and mitigation to climate change, it was important to consider that some solutions had negative effects sometimes and should be integrated in the risk assessment. Another advance of the last assessment report number 6 of the IPCC with this kind of synthetic view, integrative vision of different concepts, vulnerability, adaptation, resilience, and risk, in a kind of dynamic view, which propose to make reassessment of the risk because it's quite evolutive. So it considers that starting from a risk situation where the resilience state is a little below, it prompts solution of mitigation, solutions of adaptation, which will permit to increase a little bit the resilience state. All these solutions on the pathway of transformation towards climate change, but also other societal goals, will introduce some emerging risks, some new solutions which are not very well adapted or negative to some aspect that will decrease again the resilience state and prompt a new evaluation of risk and a new circle, a new loop of assessment. So we are entering in a certain level of complexity of risk evaluation, and a lot of terms have been imagined to this concept, but only 2 of them. All these terms have appeared in the literature, but the IPCC have only introduced the 2 first ones in the last glossary published in 2018. The notion of emergent risk and the notion of compound risk. This notion of emergent risk comes from the fact that adding new solution to the risk situation, it might create new risk. For example, when there is a problem of water scarcity and we want to reuse water, there is sanitary problems that can create very new health problems for human population. So this is a kind of emergent risk with a new technology which is the reuse. And compound risk is a little bit more ancient. It's a notion of interaction between hazard, mostly in the hazard component, which will create very important effects, interaction that of extremes, climate extremes, for example, that will increase the magnitudes of the effects. This has been a little bit developed by these authors in the climate domain. Finally, using the old framework of the IPCC with still the climate outside the risk system, they focused on some climate extremes, which is are here in the climate drivers that they consider come very important for increasing the magnitudes of the hazard, and maybe some also non-climatic drivers acting on the other component, but mostly on the hazard. Finally, here Pescaroli and Alexander did a global literature analysis and did this categorization with the fourth category. We find here again the compound risk. The interacting and interconnected risks are quite similar. The difference is mostly here the introduction of some Earth discipline with physical dimension of the hazard, interacting with natural hazard, but not so much at that here interacting with society and governance and human organization, a little bit more in the interconnected risk, where finally it is more around a global vision of interaction between human, environmental, and technological system. And finally, the cascading risk, you know it quite well, is to make a long story short, it's more likely the interaction between natural hazard and human infrastructure in terms of NATEC technological assets. Well, coming back to the IPCC and the way to represent the complex risk, well, the IPCC adapted the Simpson notation with, here you find again the color codes for the several components of the risk. And compound risk might be unidirectional, bidirectional, or cumulative, aggregative, or a more or less long or complex cascade of risk. And finally, it can be integrated in the final framework, including the response with the declination of the different kind of complex risk inside each component of the propeller on the different blades. Let's now, to finish, illustrate with some example, mostly on the forest domain. This is the study case of the 2018 fire disaster in the seaside town of Mati in Greece. I don't know if you remember this catastrophic event. It is a small paradise where a lot of people have holidays, but it became a true hell when a forest fire came with a blowing wind from the interior to the sea and go through all the city full of tourism. And people were obliged to refuge in the seaside. There were 100 fatalities. It is the most important number of fatalities in forest fire in Europe, more than in Portugal in 2017, in just one fire. And Simpson analyzed this catastrophic event using the framework we have seen just before in terms of multi-risk. And it was a quite interesting analysis, mixing climate extremes, which were common to all parts of Europe, but in this particular case, interacted with other considerations, which makes the catastrophe even bigger. First, difficulty to fight due to several factors. The poor spatial planning. Urban planning in Greece is quite poor, and the intermixed of vegetation and construction made human at risk. And also the evacuation order, the way the crisis was managed was quite badly organized, and it increased the magnitude of the And all this interacted with some failure in some infrastructure, including electrical infrastructure. So this is a typical example of a threat coming from the forest and finally impacting to all a series of other assets. In the forest domain, we have a long list of threats, biotic hazards, pests, disease, insects, but also abiotic hazard, drought, fire, windstorm, heat waves. All these can combine and increase the exposure of, well, there are the forest itself and its ecological services, but in terms of impact, a lot of possible loss, biodiversity, wood quality, productivity, wood productivity, and finally, dieback and mortality. And the soil condition, the station condition of the forest can bring some vulnerability factors. And the foresters and the risk managers used to apply some classical silvicultural actions like pruning and thinning. Some specific one, for example, for forest fires, we have already seen the fuel management, which is the key one. But after the crisis, there are other actions that can save some values. For example, the wood, if we do a salvage harvesting sufficiently early for the wood industry, but also to prepare the next crisis by action that will mitigate the next disturbance. I would like to illustrate it with a study case we are working on with Nicolas here, which is leading the Rimini project, which is an internal project of INRAE, meta program, on risk and multi-risk. The question is it different concept and formalizes them? And we use the study case of Landes de Gascogne with the forest of La Teste de Buche, close to La Dune du Pilat, very famous place, where we had a fire in 2022 in a very special forest with a very special land tenure status. The wood belonged to the resident of the neighborhood of the neighboring cities, and the owners of the forest can only exploit the resins of the trees. So it leads some conflicts between the two communities, which blocked any forest management and fire protection actions, so that the fire came in a forest with no preparation, no anticipation. And this was the cascade of risk we have analyzed with three risk propellers. Here, the one of the drought, here the one of the wildfire, and here the one of the insect at the end. So in spring 2022, a big drought started to impact the forest with some dieback on the living trees. Here are the solutions. In brown, the solution that could be applied, but was not applied. No work in the forest, no thinning to limit the consequences of the drought. When the fire occurred in summer 2022, of course, it was a very high risk of mortality. It is almost a total mortality of the trees. And here, they could have done some fuel control, but they didn't. So the only thing they could do in orange, that was done, post-fire tree cutting. These are the trees that has been cut. But the problem is that it was not evacuated, and it remained several weeks in the forest, and the insect started to multiply in this stock of food. And the third, finally, the third hazard arrived, the scolyte multiplication, which that time killed living trees that has not been burned but was around the burned forest. So an additional mortality. They could have removed early the trees, they didn't in brown, but here in yellow they had to do sanitary felling, which correspond of higher loss that was, and the reason why it was because a bad solution on the previous risk was applied. So it's quite important for the multi-risk approach to introduce the solution blade that permits to understand really the chronology and the causality of things. Let's finish with a huge program that is just starting in the framework of the PEPR forest. So you heard about the PEPR IRIMA here in Grenoble with a lot of partners working on the risk in general. PEPR forest is dedicated to forest. There is several domains of research, regeneration, monitoring, and one domain is multi-risk in forest. And it is one of the only PEPR dealing with multi-risk, to my knowledge. So it's coordinated by INRAE. It's with a lot of establishment as partners. You can see them here. A long duration, 6 years. It's long for a research program. It's funded by the French National Research Agency, which reasonable budget. And it's just starting this month with the launching meeting. It means in mid-September. The objectives are to integrate the multiple risk concept and dimension in the societal and scientific issues related to forest. And there is 5 main axes. The first one is the continuation of the Rimini project to go through the concept and the way to modelize the multi-risk. Are they different from mono-risk? And how to have this synthetic consideration of risk and how to quantify the modeling. The second axis is the monitoring, how to make a monitoring considering several risks together, a monitoring of the forest. Nowadays is very in silo monitoring of the forest. It has to be integrated. The third one is a modeling approach towards a platform that enables to make forest dynamic trajectories, including the severance threat applied to the forest. The fourth one is more sociological axis with how does different stakeholders have a perception of multi-risk and vulnerability of the forest. And finally, an axis dedicated to the solutions, to the governance and management strategies, taking into account trade-offs, and trade-offs are very important, so as some solutions have not negative impacts on others, on other risks. This graph is only to show you that to do so, it is not, we have to go out of the forest domain. The risk system, the perimeter of the risk system has to be expanded to take into account the neighboring sectors that can be impacted by a forest fire or any risk in forest, urban interface, all the network, and other sectors. And each of these sectors have to implement in their own defense plan against incident the risk that come from the forest. That's it. Thank you for your attention. Some second message.